We're going to study the RDBMS basics today. See, we have been discussing client-server architecture, client-server RDBMS. You know, we call this guy as client. We call this call as business logic layer. Right? Okay. So we have been discussing these three things, right? Right? We know about client a lot. Position, responsibilities, all those things. They're kind of business logic. You know, I told you, right? These are the rules which get executed in the business logic region, right? But what is the database here? We know that is where the database is stored. Is it right? Right. Today we'll try to understand how the data is stored, just to get into the basics of data. Okay, that is our goal. We'll try to get into the database. We'll try to understand how data is stored. Anybody knows anything how data is stored? Do you know, John?
No.
Have any idea? Have you ever heard of tables and columns?
Yeah.
What are they? This is the list of some providers, all providers. Okay. This list is nothing but an Excel for you. Is it right?
Yeah.
Right? We store the data in the database exactly like this, like in the form of an Excel file. Okay. Table is an Excel sheet and columns are an Excel column and rows are one record, a particular record. That is the equivalence between this thing. Is this equivalent 100% similar? If you ask me, yes. If you can envision an Excel, that is what you're looking at on a table. If you can imagine an Excel in your mind, that is a table. So account data is stored in the database in an account Excel sheet. For all practical purposes, for us, this is right, because we will not be making database administrators. We will not be doing any administration of database. So we don't need to know how is this Excel different from the database. We need to look at the data. When we look at the data, it will look exactly like that it looks in Excel. So for our purpose, there is a 100% similarity between an Excel sheet and the data in the table. When we will fetch data from a database to look at it, it will look exactly like the data fetched in an Excel sheet. Okay. In fact, Excel allows you to see data. You can get data from a database. You know, this data is entered by me or somebody. Actually, this data is we got like that. Okay, we got this data like that. But Excel allows you to see get the data from a database also. So in that way, database, Excel is a querying tool. Excel can query a database, get the data and show it to you. How is Excel possible? Because Excel format is pretty much same as the format of the data in the table. The way data is stored in tables, that's the same way data is stored in Excel. So when you will look at the data, it will look exactly like this. Okay. For our analysis purpose, we will think of tables as Excel.
One more thing before we go further.
Mr. John.
Yeah.
This record is highlighted. Can you tell me what is the first name of this record?
And
last name?
Taylor.
Payer?
Railroad Medicare.
Authorization ID?
17822.
Provider key?
133338.
Doctor's INS ID?
POOD 93869.
Yeah, that's fine. What is the date sent?
12th October 2004.
Perfect. See, isn't it the way we work with the data? Let's say anybody who has worked in any company where he was storing something, आप भी Excel बना सकते हो, right? Yes. Right? Where to? क्या बोलते हैं? Money? Fair. Right? Yeah. You can make an Excel like this, right? Yeah. Right? Yeah. Right? How will this Excel help you, Hafiz? Do you think this Excel can help you?
Yeah. Yep. To keep the record intact.
Yeah, it can help you in making sure, like at the end of the week, you want to make sure how much money you made.
Yeah.
And it will help you, right?
Yeah.
It will help in managing your finances. Similarly, you can make another Excel.
Expenditure.
Exactly. Store. Right? Right? John, I want to make an Excel of expenditure. What do you think? What are fields I should make?
Like your, how much you're spending on food.
Okay, food. So food, where should I put food? Should I put it in the store? Where should I put this thing?
Under bill.
Bill will be like how much money? Bill amount.
The expenditure is like whatever you incurred from a part, like that's expenditure.
Okay.
Bill is what you're supposed to pay, like your monthly electric bill or telephone
Okay.
bill. That's
So
it.
let's say okay. So where should I put telephone bill? 40.
Yeah, right.
Date is
whatever the date is due.
no this or date due. Okay.
Date due or when you receive the date and you
So
can
when
put both.
But yeah. So date this one date
Yeah,
paid right. This is a different thing right.
yeah,
Right. Right.
yeah,
What telephone bill?
yeah.
Do you think this heading is good?
No.
What heading would you like to keep?
Utility.
Right.
Yeah.
Right. So let's say I went to Walmart. What should I do?
That's your.
Where should I put it? I went to Walmart yesterday and I put like I spent how much? $107. You spent $107. Can you tell me where should I put?
Expenditure.
Sure. What should I do? Which field should I put?
Miscellaneous. Like office supplies, miscellaneous, whatever you want to do. If you
Okay.
have to do something with your business, then you should put up office supplies.
Okay, it was office supplies. That's correct.
Yeah.
Okay,
Then if you want, you can get a code name for the office supplies.
so date due. What should I put date due?
There is no date due because it's paid. It's already paid.
Okay, so what is
If
it?
you do the credit card, then you put like when the credit card bill is due.
Perfect. I like that line. See, that means that is not applicable,
Yeah.
right? Right. So it will you leave it null. This is not applicable. You leave it null, right? Right. This is the way data will be stored in database for all practical purposes. Okay, and okay, let's do one more thing. So there will be many such as for groceries and telephone cards and this thing, right? Is it right? Right. So at the end of the month, you'll have to do the total of groceries and everything. Is it right?
Yeah.
So let's maintain a category, right? You have-
Grocery, you can like put it like food and papers and napkins and whatever. Plastic forks, knives, you can separate. So you know how much you actually paid on that. What junk you're spending, how to cut it, you can do that.
right? Right. So we can categorize these things also. Is it right?
Yeah.
Right. So this is pretty much a table. How a table looks like. It has a lot of data. How many transactions you would be having in a month, in a week? You must be paying bills and buying stuff. You think 5, 6, 7, 8,
Yeah. It
Maybe
varies from month to month.
maybe more.
Yeah. More than that.
You must be going to Kroger maybe 4 or 5 times. You must be paying 500
Yeah.
bills. You must be making 30, 40 transactions in a month.
Oh yeah, easy.
How many transactions you might be making? Can you give me a number? 100?
Yeah, it's 100.
Right? Right? How many
Yeah.
transactions you might be making?
You should be more than that.
Yeah, right?
Yeah.
There's so many transactions in there. Sometimes we just go out, we make a bill. That's one transaction. So we'll put it here, right? It's one expenditure, right? So we'll put it separately. Okay. Okay. So this is a way, pretty much the way that the database looks like. Here he's trying to say, these are the providers he's working with. Okay. This is their first name, this is his last name, this is his pair, this is the authorization ID, this is the provider key, this is the doctrines ID, this is the date sent, this is the date approved, entered by date for this guy. Okay, so now we understand, right? Do you also try to keep track of who went to who did it?
Yeah, because when you write a check,
Yeah,
Right,
you found out right at the end of the month that Nalini bought all this.
Mhm.
So if you don't do this thing, you cannot do that.
no.
Right? So you have to keep track of who did it, right? Right? So you will see the number of fields will keep increasing for expenditures of form. Okay, it's a lot of expenditure.
Yeah, it's not possible to write it down on a piece of paper and notebook because it will be all here. Because once you get a used notebook or paper slip,
Difficult to
and
find
then
information. It's difficult to total. It's
Yeah.
difficult to sort.
Yeah.
Let's say I want to find out, let's say I want to find out who did it. So what I can do here is put a filter. All the expenditures of John, all the expenditures of Nalini, all the expenditure who is not known, we do not know. These are all the expenditure of John and Nalini. These are all the expenditure. Is it right? Is it right?
Yeah.
Right? So we want to make these queries, right? We have to find a way to look into the data and find out who did what.
Yeah.
Right? Similarly, we'll be doing database operations on this thing. So this is one query, right?
Yeah.
You also want to find out how much you spent on groceries. Is it right? Right? And how much you spent on a particular date, 10 December. Other dates are not there. December, this much I spent on 8 December. This much I spent on 1st December. This is what I spent on 10th December. Did you make this query? Do you like this query? Did you like this way? Did you know this thing
Yeah.
exists in Excel?
Yeah.
Did you know this thing exists in Excel?
I used to put my stuff in inventory in store, so I know that stuff. I used to do that every day.
Really?
Yeah, inventory control every night.
Right.
See, I put like this many cases of beef you have, hamburger. You truck bought this much in the truck. So how much we got? How much you used? How much is not counted for? How many they stole? I can find out.
How many not accounted for, right?
Yeah.
Right.
Unaccounted.
This is pretty much unaccounted ones.
Yeah.
Right?
That's
This
everyday thing for me.
Yeah. So this is querying. We are trying to find out how many transactions have been unaccounted for. Is it right? Is it right? Yeah. Right. So this is the query. We made a query. Pretty much database class is over, if you ask me.
Yeah.
We don't need to know anything else. We need to know how the data is stored. We need to know how the data is retrieved. You found a way. Actually, the only thing is you do not know how to work on Toad. And you don't know how the data is stored in Silo. But database operations and storing data in database is over. This is the way data is stored in over. This is the way you query for data, and you pretty much knew. Do you ever group the data also? Like only office supplies things?
Yeah.
Right.
You get number for everything. Like this is your net sales for the whole month. That's your projected sales. How you have plus and minus for the month. Then you got food, paper, bad checks written to by the employee. When you take checks from the customers. Now there's no more problem. So you put like gross sales, my food cost, labor cost. That's your main item.
Right.
You get your labor cost, your food, you make more profit.
Yeah. So you put your total food cost. You calculate it from all the food
Food
costs.
is like food and paper together. So like we're allowed 27%.
Okay.
Labor we're allowed 17%.
Okay. Perfect. This is one such report. How many total number of accounts are there? How much is the total volume of those accounts? Right? How many were referred to sales? How many are cancelled? How many are in queue? Is it right? How many are
increment on the waiting list?
Yes. How many are preliminary work done? How many are installed? How many are installed? Is it right? Making sense?
Yeah.
Right? And then there is a totals. The number of days which has been between 1 on 10 to 11 to 21. Basically, how many accounts have been aging? How many days nobody worked on them? For 10 days nobody worked on them. 2 accounts are like that. Nobody worked with, these one account is of such like the hit has not been worked for 11 to 20 days. Nobody's worked on this. Nobody worked on this one account for 21 to 30 days. Right? So, okay, there are one account which has a 21 to 30 day delay. 21 days has passed and nobody's worked on it. Or 30 days between one of these ranges. For example, I want to know how many accounts have been delayed, like how many candidates, let's say, he calls people back, Bob calls people back. We have 200 candidates. How many candidates you never thought? How many candidates have been waiting for the last 10 days? How many candidates have been waiting for the last 15 days? 10 to 15 days. How many candidates have been waiting for the last 15 to 20 days? So these are the accounts which have been waiting for the last 1 to 10 days, 11 to 20 days. These are the numbers. These are the totals for those. This is an aggregate report. Is it right?
Yeah.
Similarly, this is an aggregate report too. How many total accounts are there? How many number of accounts are in refer to sales? This is the way to read it. This one. How many are cancelled? How many in queue?
Preliminary work, how many done? Map test, ready to be scheduled.
Perfect. Right? Making sense? Right? Okay. This is an aggregate report. How what we do is we get the data from Excel, then we make work on it. We work on it and then we combine it. Like here, we can say let me just spelling the incorrect. So let me say there are two groceries. So I say grocery bill is total how much? 25. So I want another report at the end of the month. How many transactions of groceries will be here in this thing? Right? There will be many transactions, but here I will see it only once. So this is a report of me.
Yeah.
Is it right? This is how the reports work. And groceries 25 and this gross unit she must have spent like maybe just once, right? She must have just spent like just once, right? Is it right? She must have spent like 2 times, 3 times, or maybe 20 times. But when you see the gross only, then you come to know how much total one person has spent on telephone. Is it right? Is it right?
Yeah.
Right? Yeah. So we have these aggregate reports, and these are these. So from looking at the data, we should be able to get this thing out, right? Do you know how to get this thing in Excel? Let's try to do that. मेरी जरा guide करना अगर मुझे गलती होती है, ठीक है? हाँ जी. Tools, pivot table कहाँ होती है? Go to data, pivot table, okay, right?
Yeah, default options. Next, yes. You select the whole table from here. Yeah. Go next.
Right?
You want to paste in the existing worksheet.
Right. Yeah. Right.
It'll start from 4i. Is that okay?
That's okay. But yeah.
Now you drop your fields.
Right.
Maybe you want to know the bill amount, so you'll drop in the data, drop data items. So that
Right?
yeah, it's done.
See, I made a total report. Did you see the report? How I made the report? Right? I wish we had a lot of data so that you could get some benefit out of it. You want to bring your data tomorrow? We'll work on that data. We got a total report. Previously, we were just querying this data. Now we got a total report. Is it right? I can cut paste it. Okay. The total. How much we spent on groceries? 25. How much office price? 107. Telephone card 6. Telephone 40. What is this?
There are 2 telephones.
There are 2 telephones. Huh? This is a landline telephone. I will never be able to type correctly. Please.
Oh no, I understand.
You understand, right? I hope. Right? Anyway, so now we see that it's accurate. Telephone bill is like this $40 only. It is also showing the $40, right? So it is pretty much. We call it group data. We aggregate report. This is a report you need at the end of the month, right? So if we get all the transactions from our Bank of America account, we can get this kind of data from there. How much did we pay to Bank of Walmart? How much did we pay to Office Depot? How much did we pay
Yeah,
to...
they give you your summary at the end of the month.
They do that?
Yeah.
Yeah, they do that like this. They do it automatically.
Check number such and such, written to such and such. If it pass the bank, if it's default or something else.
Right? So now you know, right? These are the 2 operations that I usually perform on the data. Other operation is, you want to sometimes see it in the sorting order. I just sorted it by GLOT. It is sorted. Is it sorted, Mr. Hafiz?
Yeah.
It is sorted. Let's sort this one also. It was already sorted. Let's sort it in another way. It got sorted in the reverse direction. We call it descending sort, right? Right? Anyway, these are some of the operations you perform on the database. The problem is that you guys do not know how to perform this data, how you really have to look at this data in Siebel, how to do these operations in Siebel. But operations are clear to you, is it right?
Yeah.
You sorted the data, you got the aggregate report out of the data, you grouped the data basically, right? Group the data according to the utilities, then you created this data, then you could look at this data, you retrieve this data, you could, in this case you just open the file, you could see it. In Siebel, retrieving the data will be a little tricky, okay, but you know, right? You know, right? Is it right? Okay. Before we get into Siebel data, we will just try to see how to get the data in the database. This is in the Excel form. Okay. We'll now look into the data, some easier way of looking at the data. Okay. Okay. The tables in this database, or there are many Excels in this database. These are all the tables available, or all the Excel sheets available. Are these all the Excel workbooks? No. You know what is a workbook, right? The whole file of Excel. But in every file there are 4 or 5 sheets. I'm saying table is same as sheet, not the workbook. Okay, workbook is almost same as database. How many sheets are there in this workbook? 3. 2 are blank, but there are 3 total. Okay, so how many tables, how many sheets are there? Maybe like 50, 60, whatever is there. Okay, I just want to make sure you compare the right thing. So sheets, same as a sheet. 2 sheets which are very important: account and contact. This is what we will study the most. Okay, we are not studying Siebel, we are just studying account, the way the data is, the way data is stored in a database table, so that you can see it is same as that or not. Okay, it is from one of just a minute. We'll look at this database. It is a database of a company. Okay, I don't know much about this company though, but we'll look at it together. So this is the employee table. Employee table is nothing but employee data in an Excel.
Yeah.
When I open it, I see an Excel.
Yep.
Isn't it the same as Excel? The only thing is it's gray and brown. It is gray and black and white. This Excel was greenish, right? Green, and blue and gray and white. To me, it is same.
Yeah.
Okay, but this is not a report. This is a table, right? This is one of the Excels, right? Right. So let's see what is in this thing.
Yeah.
The employee ID is there.
Yeah.
Did you have an employee ID where you were working, John? That is what it is. Last name.
Hard date, pay rate, everything.
First name. Tell me one thing, John.
Yeah.
The first name of Mr. Devolio is Andrew.
First name of the video is Nancy.
Nancy. Okay. What the title of Miss Nancy is Vice President Sales.
Sales representative.
Okay. The title of courtesy.
MS.
MS. That is Miss, right? Birth date, hire date, address, city, region. Everything is written here. Is it right? The notes are also written. Right? What does she do? What she does not do? Whatever.
Yeah.
So this is the employee database. Is it right?
Yeah.
So this is an employee Excel. These are the customers. How many customers this company has? 91. By the way, how many transactions were here?
3.
3,
Oh, no,
7.
No.
Right? Right?
Yeah.
Okay, we'll come back. So there are 91. So one of the other transactions that we find from the database is how many records are there. Okay, so these totals. So totals away, groups away, and queries. We'll do all this. It's very simple. It's very simple. But okay. Order details. See, this is the order details. What was the order ID? What was the product purchased? Unit price, quantity, discount.
Yeah.
Sorry, these are the orders.
Yeah.
This is the order ID. This is the customer who gave this order. This is the employee. This is the order date. This is the required date. This is the ship date. This is the ship wire, how I shipped to him. This is the freight. This is the ship carrier name. Right? This is the shipping address. This is the ship city. This is ship's region. This is ship postal code, ship country. Right? This is the address where we shipped. We have put everything in a separate field. These are the various products that we have. We make chai, we make cheng, we make aniseed soup. Right? We have this exotic liquids. These are supplied to us by exotic liquids. Is it right?
Yeah.
We're just keeping track of each and every.
Yeah.
This is the category. This is the quantity per unit. This is the unit price. So that means, right? This is the units in stock, units on order, reorder level, discontinued, right? Okay, this whether it has been so this one has been discontinued. You think it should be sold now? No, it shouldn't solve. That is the whole idea, is maintaining this flag, right? When in the GUI you put a flag, it gets stored in the database here. Making sense? In the form of an Excel. Actually in the form of a table, but in the form of a record in a table, right? With various columns. We know that. But it will look like this. Isn't it similar to Excel? What is the main difference? There is no difference from our discussion, if you ask me. Our discussion can be completely done because we will be doing data analysis. We will not be doing database administration. We will not be creating tables. We will not be creating columns. How do you create Excel files? We just click a new. We just go to this thing, desktop. We just come here. We right click. We click new Excel. Right? It is very easy. It is very, we right click, right? That's how we create, right? It is very easy for us. We know how to create that. How to create a table. That's a skill. That's a big skill. It's not easy. It's not same as creating Excel. But so that's a huge difference. But I will not address this difference in this class because our goal is not to become a database administrator. Our goal is to understand the data, how the data is stored, what are the data relationships, and we will keep going on that path. So from our purpose, Excel and table are same because table shows the data in the same way as Excel shows the data in the same way as the table shows. Okay, how the Excel is deleted? Highlight the Excel, click the delete button, right? But how the table is deleted? No. It's a special skill. Okay, we'll discuss all that. Sorry, we will not discuss all that because that is a database administration work. But we will understand how the data looks like because that work we might have to do as a data analyst. You might have to do as a data analyst. Okay? Isn't this pretty much the way data looks in the GUI? What do you guys say?
I don't know nothing about GUI.
No, this is GUI.
Oh,
see, this is how your products look. Let's go to product screen. We are in the all product screen. This is pretty much how it looks. Is it right? Right?
Yeah.
Right? What do you say?
Yes.
It's divided into different.
Right?
Yeah.
So actually your understanding of the GUI is pretty much enough. Like you want to, but the only thing is in GUI you cannot do the total. How will you do the total? Do you know anyway? You'll go click, right? In here, I did one click and I found out that total. I just did one click. So database has some other easier ways of working with the data than the GUI. In fact, to do your data analysis, you never needed to go to database. You could have done it in the GUI itself. But GUI has limitations. It is easy. It is easy, but it is slow. You know that Siebel 7, it never opens, right?
Yeah.
Right? But it's very easy to work in the Siebel 7 backend. Let's work on the Siebel 7 sample. Okay? It's a little tricky, but I'll show you. Okay. So it was quite easy for us to get the data, right?
Yeah.
See, remember like that Siebel 7.5 does not start sometimes, but so in this thing, we are right now looking at the data, directly data. We just used another tool, just a little tool to attack the data from here. We are looking at this data. Usually we look at the data like this. Usually we look at the data like this. What is the difference by looking at the data here? Difference is the speed we will get because all the business logic occurs here. All the code is written here to manipulate the data, and the client presentation data, that code gets executed too. So it takes a lot of time. But when we look at the way data is stored in database and directly access it, actually, let me correct one thing. It should be like this. Right? We'll directly access it, right? So we access the data from here to here, and here we are just directly accessing it or directly reviewing it. That's the only difference. Otherwise, it's pretty much same. But that makes a lot of difference because the speed will be faster, right?
Yeah.
And you saw the difference in speed to see all the records. And I can see the total number of records also, 1082 rows in the query. Very quickly did I saw. If I want to see how many contacts are there, How many contacts are there, Mr. Hafiz? 9192.
No.
If I go in the GUI, what I have to do is click, 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 click. First I have to look for this guy. Then I come here. Then I click, 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 click till I go to the bottom, right? Then I would see all this, right? Anyway, you see the things might become much different and much easier. Is it right?
Yeah.
Right? So that is a very reason why we work on the database directly. Okay, so let's continue our discussion of how to work on database, right?
Yeah.
We were in this product database, right? So we are again looking at the product, quantity per unit, unit price, right? This is the way exactly it is. It will look in the GUI also. The only thing is might be in the form of a form like this, but it will be in the form of a list like this. So it pretty much is like the list. Then what is the difference? I'll tell you one very big difference. Difference I actually stated little bit. This here. There's a lot of work occurring here, and that is the main reason. And then this client, see, whatever you say, this is still little less useful to the eye, not good for it. You cannot do so many things on it, but here you can do so many things. You can drill down on this thing. You cannot drill down on this thing. Supplier name, tuck. I cannot do that. Here I can, and I can look at the address. I can click on this and I can look at the address. I can do so many things, whereas here I cannot do it. There is no relationship between the data. Is there a relationship shown in the data? No. There is no easy way to navigate the relationships, even if it is there. Here, it is very easy way to navigate. Then, the data is eye savvy. And then second thing is, data is also present in the form of a form, which is easy for us to enter data in. Right? When you enter data, you click here new, you start entering like this. Isn't it the way you guys entered?
Yeah.
Right? Is it right?
Yeah.
So, it is much different, but there is a very big difference in this thing. Remember that account? If you want to see all the accounts and their corresponding contacts, these are the profession affiliations. This one, see, you can see it. This is the difference in the way. This account, these are the contacts associated with that. In table, account will be in the account table, contact will be in the contact table. For example, this account, let's say the various products with this account. Let's see various orders of this account. Okay, you see accounts on the top, orders on the bottom. We know that we made these views, right? We made these views, and these views are written somewhere here in this drawing. Somewhere here, these rules are written. How? And then in the client, we put account on the top and orders at the bottom. But they are not stored like that. They are stored in separate tables, as we know, right? Orders are in this table. Orders are in this table. Customers are in this table. This is the way the data is stored always. Every entity is in a separate table. The relationship between entities is generated in this layer. That is the whole idea of manipulation. This is the main funda of business logic layer. It is not only about the rules. Other reason. When we are entering data here, we can put rules here. We will put rules like, let's say Edelman. Let's say you want to put a rule that last name should not be this or that. Like it should not be having comma or it should not be having dollar character. Second thing is in the amount. Let's say you go to the order screen. Okay, let's say in the order, and we are putting the currency. The currency can be only one of these. It cannot be a ABC. Right? This rule can be put in this layer, or in this layer, or in any combination of this layer. We discussed that where we should put the rules, right? Remember, right? Where we should put this kind of rule. Tell me, USD should be it should be one of the currencies. It is put in the client itself. This rule can be put in the client itself, but that's immaterial. From our that is very important from that day's discussion point of view. From this day's discussion, what we're trying to say is a rule can be put, but in database there is no rule. You can enter the data. So that is the reason users never should touch the database directly, because they are not smart. They will put anything. Otherwise, we would ask them to just directly access through the access and put whatever they want. We cannot put rules. We want to put rules so that users don't enter wrong data. Is it right? Right? You remember when we were working in this Excel? I was putting telephone as TLEFENS. There was no way anybody could stop me. Right? I was putting whatever. Sometimes I was putting groceries. Sometimes I was putting groceries, something like that. My spellings were wrong. In this thing, you can make sure in the business logic layer that in the client the data is always entered correctly. For example, remember that status. Let's say account status or the order status. Do you think I can ever spell it as COLOSCD?
No.
I can always spell it as closed, the way it is written here. So this is the logic. We are restricting. There is a code written behind the scenes which is not letting me enter anything other than closed. Is it right?
Yeah.
How Siebel writes that code, we'll learn all that, right? We'll learn all that down the line. But our goal right now is to understand, this thing, that there is a code which does not allow you to enter COLOSCD. Whereas, who could stop me from entering it here? Nobody. There is no rule. That is the reason people do not like Excel. Otherwise, Excel is as good as Siebel. But in Excel, you cannot put rules. Right? There are so many other problems in Excel. That is why people do not spend $100 on Excel and want to spend $100 million on Siebel. A typical Siebel implementation costs
There
like
is no privacy in Excel.
Exactly, about $10 million. Yeah, it's not a simple thing. But when they take the decision, it's a very well-informed decision. They know the benefits they will get. They know that they can restrain people from entering wrong data. They know that data sharing is very easy. For example, that is one very important factor. Let's say you enter some expenditure in this thing, Excel here. Do you think Bob can see it in India? No. But if I'm using Siebel, I can enter something here and Bob can see it in India. And we do have an application like that. Like we make Excels of people who call us, right? We make Excel of people who call us, or people who are studying and all that stuff. We put it in Excel, then I have to send it to Bob. Bob, these are the people who called me today. Please call them tomorrow. Is it right?
Yeah.
But we don't do like that. We have a better way. We put everything on a website, and he accesses the same website. So if I enter something here, next instant it is available to him. Making sense to you? Making sense to you? So this is the way. This is another benefit. Data sharing is very easy. There are many other benefits because of which Siebel is a hit, and Siebel can charge $10 million for something for which I spend $20. Right? There are other benefits also. We'll discuss all these benefits one by one. But I want to make sure the data understanding is complete. Why do we need tables and columns? To store data. When it is the same as Excel, but the interesting thing is data relationships. The way the GUI is showing that data, remember that account on top and order at the bottom, that has become possible because of business logic layer, and that is the strong point of Siebel, strong selling point of Siebel. It shows the data relationships very, very well. Okay? Let's come to this one then. Okay. So how are the relationships? Okay, these relationships are good. I understand that account. This is account. This is the account order. These are the orders for this account. Is this relationship not at all stored in the database? If this database is not stored in database, then how would it publish it here? This relationship has to be stored in some manner in the database, right? Right? Is it right? Right, sir? Right? If this database is not stored, if this data is not stored in the database, then this will not show. For example, if you do not store the data, who spent that money on the telephone card, at the end of the month you cannot calculate. Is it right? Similarly, if you don't store this relationship, this order was given by this account, then you cannot get how many orders were given by this account, a particular account. You cannot do that. For every order, you have to maintain what account made that order. Is it right? Somewhere that relationship has to be stored. Maybe there is an easier way for database to store. Maybe there is a quicker way for database to store. Maybe there is a cost-effective way for the database to store. But there is a way. Right? So we'll study. We'll study that way now. Okay? Let me do this again. Okay? Okay. The way it stores it, we want to find out who placed this order, all the details of that guy. So he does not store, like for example, this is the order. It is by the customer Wilman Kala. So we do not know what is the telephone number of Wilman Kala. We just know it is by Wilman Kala, right? It goes to it just shows the ship address, ship city, but it does not tell you where Wilman Kala lives, what is his number and all that stuff. So in the order table we just have the customer name. So the way it is stored in the database is you go to the customer and you look for Wilman Kala. It's very easy. It's the lowermost one. So you see his title also. Now you can see the contact name for this customer. You can see the address of this customer. By the way, he lives in Finland and this is his telephone number over there. Is it right? So what we are seeing is that we can get all the details of the customer. The only thing we need to store in the order table is order Excel is the name of the customer. Right? Once we get the name, we can come back and get the name and get everything, every other information. This is the way. See, the database maintains the relationship. It does not mean the database doesn't have to maintain the relationship. It does. The only thing is it does it in a different manner. Right? For example, here you see all the details of the account up there and see all the details of the order down there. It is easy in the GUI. It shows in a different way in the GUI. But the way it does is, store is this way. The way we discuss, it stores the customer information here, order information here. For every order, it stores the customer name. So what does this logic do? This logic does exactly what I did. This logic layer. It goes into the database, gets the order details, look at the customer name, go to the customer table, get the customer's detail, put the customer details on the top, put the order details on the bottom. Is it okay?
Yeah.
See? Right? So it gets the data, it looks at the account name, it looks at the order, go into the order table, get the customer name, exactly the way I did, the way steps I took. I went to order, took the customer name, went to the account table, look at the customer name, look at his address and everything, and I get all this data, put this thing on top, account information on top, order information on bottom. Right? This is the way business logic layer runs. Isn't there a lot of code written here?
Yeah.
That is what is written here. All this code to get the data, to associate the data is written here. Okay? So what we call this is something of this table has to be stored in this thing. Is it right?
Yeah.
That is called as the foreign key. In the order table, you put the name of the customer, that is the foreign key. Okay? So let's try to understand one more thing. See, did you have an employee ID?
Mm-hmm.
Right?
Yeah.
Right? Like this is the employee ID. Let's say we want to know which employee placed that order. Mr. Stephen Buchanan placed that order. Tell me one thing. Had I placed the employee ID here and not the name itself, do you think it would have been okay? Do you think I would have become confused had the employee ID written here?
Yeah. No.
Let's say, okay, here is the thing. John, your supervisor wants to know at the end of the day, who put the sticker on that. So they put your name on it. So then looks at it, Mr. John Kanungo. Okay, he's the guy who made this order. You make the order of the laptops, right? So this instead of that, he puts 111222, which is your employee ID. You think he can figure out who this guy is?
Yeah.
How will he?
Because it's stored in the database.
No, forget database. I'm just talking about common sense. If he looks at your order, looks at your 111222, he will look at whose employee number it is, and he can find out.
Yeah.
Is it right?
Yeah.
Is it right? Right? So instead of storing the employee name here, if you put employee ID here, it will be easy. It will be same easy.
Yeah.
Is it right?
Yeah.
It's not a big deal. So you can put employee ID here, you can put employee name there. The only thing is it should be unique. If it is unique, not unique, somebody will say Teddy Cow Henry Carnes. That order from the customer, sorry, this order number 10250 is from Margaret Peacock. Right? Right? You will say which Margaret Peacock? Let's say there are two Margaret Peacocks. Then what will happen? Do you think system will get confused?
Yeah.
Your manager will get confused, right? So tell me one thing. In Dell, everybody had were there any people who had the same names in the whole company Dell? Do you think there could be people who have same names?
May have, but they got different ID number.
They got different ID number. Doesn't it make more sense to store the ID number here?
Yeah.
That way system will never get confused. It is very easy for the system to find out this order
Name might
ID.
be same, but ID can be different.
Yeah. ID has to be
It
different.
has to be different. Otherwise, somebody is staying at home and somebody is working getting paid twice.
Exactly. Right? Right? So this Excel should store the ID. He's storing the employee name. I would store the ID. Siebel stores the ID. Okay? Is it any different? No. Right? Let's go to the employee table. Margaret Peacock, Stephen Buchanan. Yeah. He could have put employee ID over there too. It would have been as safe. It would have been as good as saving the name, because of the fact that name can actually be the same for people, but IDs can never be same. Is it right?
Yeah.
Is it right?
Yeah.
So that would have been very good. This ID, let's look at every table. For every table, you see we have a customer ID here. We have a category ID here. Right? Why do we have the ID for every table? Because if you want to make a relationship, we keep the IDs there. Never keep the name. He's keeping the name is wrong, but he should keep IDs. Siebel does not do that wrong. He keeps the actual ID over there. Right? This is how they maintain the relationships. You see, Siebel now, or the database, this database technology has saved a lot of space. It doesn't have to put the employee name and everything again. It's just putting the ID there, and anybody can know who placed this order and what are the other details of this order. Is it right?
Yeah.
So that is the whole idea of the database technology. This ID, which is unique for every row, this is different for this row, different for this row, right, John? Right?
Yeah.
This is called as primary key. What is the category ID for this?
Produce.
No, what is the category ID? Look at the top and just what is the category ID?
7.
7. What is the category name?
Produce.
What is the description?
Dried fruit and bean curd.
What is the picture?
Bitmap image.
Exactly. What is the category ID?
Category ID is 7.
Yeah. What is the category ID for grains and cereals?
5.
5. Perfect. Right? Right. This is called in the database. These are all called as columns, but this is a very special column. Category ID is a very special column. It is also called as the primary key, because we make sure that it is unique for everybody. Can we make sure that everybody has the different name? Is it possible for us to do that?
No.
John, what do you say? Is it possible for us to make sure every employee in the company has different name?
No.
No, it is possible, right? When a person joins, just see whether, let's say, Gaurav Singla joins. Look at whether there is a Gaurav Singla or not.
Yeah,
if
you
there is a
can
Gaurav
assign
Singla,
them different ID.
but no, change his name. Sounds funny, right? I think it is funny. We cannot change the name.
Yeah.
So we have to keep the same name, but we have to give him a different ID. That is the only way database can work. Is it right? Right? Do you know the importance of keeping it unique? Because when some other table is referencing it, right?
Yeah.
It should be referencing a unique thing.
Like social security.
Like social security is a good idea,
Mm.
right? You think by mistake people can have same social security?
No.
No.
No, right?
Unless somebody is fake,
Yeah,
like Mexican people got fake ID.
exactly. Exactly. Do you think you want to keep social security number as the
No.
primary key?
No.
Yes.
Can people, and it is good, both are right.
Yeah.
Yes, we should try to. No, but there could be reason, like Mexican thing.
Yeah.
But tell me one thing. If someday, by mistake, user enters a wrong social security ID, he's a human being, right?
Yeah.
He can enter 389-111-111 by mistake, which is of the same guy. Or he can make 389-123-456 instead of 7. Do you think 1, 2, 3, 4, 5, 6 could be of some other person now? Yes.
Yeah.
Right?
Yeah.
Right? Right? So, you're leaving your system can crash if you make the wrong statement. You think if you turn the volume by mistake, you turn it high, the whole circuitry should crash? Do you think it is a good design?
No.
No. A good design would mean it should be immune to things like the simple mistake the user can make. Simple mistake.
Yeah.
Turning the volume too high. Simple mistake. It should not lead to crash. Perfect?
Yeah.
What will you do, sir? Let me ask you guys. What will you guys do? Assign an ID of your own for every row.
System, let the system assign.
Let the system assign an ID
For
of
you.
its own, and make sure that system will now make sure its ID is unique. Now you know why system Siebel doesn't let you touch the database, because you will by mistake put a unique ID same. You'll by mistake put the primary key as same. So Siebel doesn't let you insert records. Siebel say do it here only. When you do it here, business logic layer of Siebel takes care of that. Auto generates a unique ID for every row. You know what they call it? Row ID. What will you call it? Row ID, right? Simple. For every row, different row ID.
Right.
Right? They do not use SSN. They do not use anything else. They do not use company tins. They assign a separate row ID for every row.
So row ID is a primary key, right?
Row ID is always the primary key in every table in Siebel. Right? Right? But what is the use of having it unique? Anybody forgets or anybody remembers that? Do you remember why did we start this discussion? Why the primary key should always be unique?
Primary key should be unique, so we can keep track of.
When some other table is referencing it,
Yeah. So
then it should not be referencing to two people. It should be referencing one person.
One person.
So we cannot keep names. We cannot keep social security here. We have to keep a separate social security, because other table will simply write in this order, you know, sorry, and simply write which employee did it. If the employee name is not unique, system will get confused. Is it right?
No.
Is it right? So employee ID is not unique, system will get confused. In fact, Siebel says, I don't want your IDs. I will assign my own ID. So that if somebody is referencing, if some other table is referencing this other table, then, so if instead of the employee ID is written, will you get confused? No. No, okay.
we'll get confused, but we can go back and check the reference.
Yes. So employee ID could be, by mistake, we assign the employee ID uniquely, but they can enter it wrongly,
Yeah.
right? So Siebel generates a different row ID for every employee. Making sense now? Tell me one thing. As far as referencing is concerned, whether employee name is written, employee ID is written, or whether row ID is written, do you think it will be hard for you to understand what I am talking about? Some people do not understand that. When they see a name, they understand it. When they see a number, they don't understand it. I don't know why. Making sense to you?
Yeah.
But you understand it, right?
Yeah.
You understand it, right? Instead of my name, let's say, so what I will do is, I'll do what I'm talking about. So I go back to the database, I go to employee, and I close this table first, I go back here, and I design it. I insert a new row, I call it row ID, and I data type, and then I go back to this one. Where's the row ID? So at the end. Siebel row IDs look like this. I inserted a new new column, named it row ID, and I gave it to everybody. Right now, for every record where Nancy DeValio is the employee who created something, I'm gonna put this. Nancy DeValio. Tell me one thing, Mr. Hafiz.
Yeah.
I don't know. Can you? Okay. So we have this. How many people are there in this room? Hafiz, John, and me. And whereas there is this table, order table. So any reference to any outside table, that is our table,
No.
employee table, will be saying this is a foreign key to this table. right? Important characteristic of foreign key to this table is this has to be referencing the primary key of this table. Is it right? In order, you should write the primary key of the employee table. This which makes more sense. Otherwise, the system will get confused. So in SQL, you will see in a particular table there will be hundreds of primary keys and hundreds of foreign keys. That's what we call as the relationship between the tables. This key, this particular column is equal to this column in the other table, right? For example, here this column employee is same as the employee column in employee table. Is it right?
Yeah.
Quite implied. But how will system know unless we tell him? So when we make this database, this is what we design. We make the relationships. Then we put this relationship somewhere in the system telling him this is how these are. Okay? You will be making this thing. Very soon you will be writing the business logic code here. At that time you will know how to write these relationships. First you make this relationship, you're keeping this in mind. Then you make these relationships, then business logic layer, and let system learn the relationships. When system learns the relationship, system will work exactly like the way you asked him to do. Right? Is it right? Anyway, so now we understand what is a join. Understand what is simple querying thing. Let's say you want to find out all the customers, all the order details, orders. Okay. So what you do is orders, customer ID, and order day. Is it right? We just found three things. Was it difficult?
No.
If I want to find out all the orders, all the orders that were placed on 4th of July or after 4th of July, then I will write simply like this: greater than why did I choose this date? Not work because there is Mira. Let us record how many were generated after 5th of October. So we made this query. Now we are generating this thing, 755 records. The total were obviously different. Total records were 830. 755 were generated after this date, 5th of October. Yeah. Your question was, when we have this customer and this has a customer ID, and then we have this order, and this we want to find out how many orders are placed by this customer. So for every order we are putting the customer ID. Why do we have a separate order ID, right? Why don't we use a customer ID itself? Because that will be enough for us to know which customer, for this customer, which customer placed this order, which is enough. That's correct. Why do we have this? Why do we have this order ID? Making sense? I totally understand. But what if there is a third table which is referencing this order table? The example that I gave was, for example, revenue. I want to know for every revenue item, for every record, where this revenue is coming from. Whether it's coming from an order, whether this is coming from a sale, whether this is coming from a service, whether this is coming from something else, whether we got it from whether we found it in the land, buried in the land, anything. For every revenue you want to know. So I'm putting a revenue record, Rev 1, this $100, RK, order RK, order ID 123, the one purchase order for which RK is working, right? Right? For every order, by the way, what are the products associated with an order? In every order, how many products could be there? This is a perfect example actually. How many products could be there in an order? Lot. So this product, the order ID will be same. So it has to be referencing the separate order ID. So we have to give an order ID to every order. Why do all products now should have a separate primary key? Because somebody else might be referencing them. So every table has to have a unique ID of its own because somebody else might be referencing it. Right? It can never be same. If there is a one-to-one relationship between customer ID and order, now let's see whether you understand it or not, because you brought it up. There's a customer, then there is an order. For every customer there could be only one order. Okay, let's forget order. Let's say something else. For every customer, for every customer, let's say there is only one address. Let's say that.
Yeah.
Okay? Easy for you to imagine?
Yeah.
But this is an assumption. To understand, we have to make this assumption.
Okay.
Okay? So we store this customer in this table and address in this table. Because of fact, there is only one address for every customer. For every customer, there is one address. There is a one-to-one relationship between this. This is what we call as one-to-one relationship. Okay? So let's say there is a one-to-one relationship between these two things. Okay?
Right.
Then we can have the same ID as this. Okay? But that will, I will keep one primary key, which will be same as this primary key, and I will keep one foreign key also. Because primary key constraint, it has to be unique. By mistake, something happens, my primary key constraint I will put. In that case, I can keep that. For all practical purposes, it is same basically. You are right, it can be kept. It is same. You put it row ID 10 times, it doesn't change anything. You are right, it is same. You can do that. But only if there is a one-to-one relationship. And Siebel uses that. What you said was very simple. If you say that, then this order ID, and this, we will use the customer ID here instead of the order ID. If there had been only one order for every customer, and now when somebody else is referencing this order, he would have been referencing only one order only. So it is good. Siebel does that, but not between customer and orders, because customer and orders are always many-to-many relationship. Okay? Okay? So customer to ID is a many-to-many relationship. Okay? But there is a thing called as customer to more customer information.
Customer to more.
Yeah. Siebel lets you store customer. Let's say you are storing customer information. All the columns that Siebel provides are full. Now you need more columns. Siebel provides an extra table called as extension table for every table. Okay, and that has this, and that is, we call it customer extension or customer more information. Customer more information table has the same ID as the main customer table. Making sense?
Yeah.
Okay, so yes, Siebel does that, and you must remember this extension table. Every table in Siebel has an extension table. Actually, most of the tables have. Okay, and they always have a suffix s underscore contact is the table, s underscore contact underscore x is the extension table, and it will be having what? Same primary key. Okay, so yes, Siebel does that, but I want to make sure what you're talking. And you're right. It is possible. It is possible only if there are certain things. There's a one-to-one relationship. By the way, what is one-to-one relationship? Every account, there can be how many orders? How many orders can an account give?
Many orders.
Many orders, right? Can one order be given by multiple accounts? Has it ever happened? 2-3 companies getting together and placing an order?
I don't think so.
You don't think so? So in your knowledge, the thing that you said in the database world, we call it, there is a
They can order, but they can order together.
yeah. Well, that's immaterial. What the relationship is. You know what you say. Important thing is how we will represent this thing. This is how we will represent this thing. Making sense, Mr. John? There is a one-to-many relationship between this thing. Okay? We call it 1-to-m relationship, or we put it like this. Making sense? Okay. We also sometimes put it like this. Nomenclature I've already shown you. There is one other way. That's what I'm trying to find out. Okay. Just give me a few minutes.
Oh.
This is another way to write account to order relationship. You see these multiple lines here that says that account has a one-to-many relationship with order. Other way to write is very simple. You simply write 1 here. You simply write m here. This is another way of writing. These two are the one and the same thing, but what it tells you is what is the relation between account to an order. Okay? Okay? Right? So we pretty much understand what is the account and orders of this thing. Right? Right? Okay. Tell me one thing. What is the relationship between account and contact? Is it a one-to-m or is it a many-to-many? Or is it a one-to-one? Can every account have one contact only?
No, many.
Many. Can one contact be from multiple companies?
No.
No.
One contact can be only for one company.
Okay. But just think, I'm your contact and I'm your contact in Avixo. Is it right?
Yeah.
I'm also your contact in my company, Cisco, where I work. And I go to the client side. Is it right?
Yeah.
Right? So a person can work for two companies sometimes.
Yeah.
Can a person work for two companies?
Yeah.
So can he be part of two companies? Yes.
Yeah.
So then he can be your contact in both the companies. Is it possible?
Right.
Right? Business wise, it is possible. So database wise, it should be allowed also. Right? If you
Yeah.
cannot store this in database, there is no way. But let's first see how we represent this thing in database technology. Okay? We represent it very simply. Just like this. Just like this. Many to many. And we put it like this, many to many. This is the way we represent this thing. When somebody says account and contact is many to many, what will you know? This is what you will know. Tell you one more thing. It depends on every business what is their relationship. Just to let you know, it could be one also for some business. Just as you said, Mr. Hafiz,
Yeah.
you said right, account to contact could be one to m. Relationship between the same two entities could be different for different companies. So when you go there, you find out these relationships for them. Okay?
Yeah.
So you will very soon understand what the relationships are. There is a thing called as a entity relationship diagram. That's what they draw. And using that, you can find out what is the relationship between the two tables. Okay?
Okay.
Okay? Here, I just showed you two representations. Okay? Give me a few minutes. Entity relationship diagram looks like. It is saying between this table and this table, you know, this is the relationship. Okay, it doesn't tell you one to m many though, but if I will draw this diagram like this, I will put this one and this m. I will put that also. Give me a few minutes. Okay, I don't have any other diagram to show you, but this is the way the diagram will be written. Let me show you that. This is an entity relationship diagram. It tells you between account and correspondence there is there is between account and correspondence there is one to many relationship between account and correspondence. This is account table, this is correspondence table. There is a one to many relationship. Is it right?
Yeah.
Okay, too much, right?
Yeah.
You will be given one such data, one diagram, and you will have to find out from that diagram what is the relationship between two entities. Making sense?
Yeah.
This is how you find out. Okay, between account and activity,
Many to many.
many to many, between decision issues and account. John, what is the relationship between decision issues and account? This is account, this is decision issues. What is the relationship? The relationship between account and activity is also many to many.
Many to many.
Account and address is one to many.
Mm-hmm.
Okay, one more thing. Relationship between address and account, different.
Yeah.
Many to one.
Many to one. Yeah.
Account and
Many
address.
is one.
Account to address, one to many.
Yeah.
Address to account, many to one.
Many to one.
So let's come back to this thing. What is the relationship between account and contact?
One to many.
What is the relationship between contact and account?
Too many to one.
Instead of too many to one, I will say many to one.
Many to one. Yeah. I'm just. Yeah. Many to one.
Okay?
Yeah.
Perfect. For every order, remember we had to put the customer name because there was a one-to-many relationship between order and customer. Shall we put can we put all the orders in the account, this thing, in the customer table? Can we put it?
No.
Can we put it? For every customer, we'll put all the orders here. Is it possible to do that?
No.
No.
It's very confusing. You can do it. You can do it, but it's very confusing.
No, you
You
cannot
can
do it.
do it. You can do it.
You can't do it. Because for every customer, we have one row.
Yeah.
Yeah.
And in one more you can put multiple orders. Did you notice something? So if you want to maintain the relationship between customer and order, where do we maintain this relationship? In which table? Customer table or order table?
Order.
Right?
Table, yeah.
Right?
Yeah.
How do we maintain this thing? Can you tell me please? How did we maintain? Can you tell in your own words, how did we maintain?
We maintain different orders, but assign the
To the same
secondary key, primary key of that customer in each order.
Yes.
So we can see who is the person who ordered.
Yes. We store the primary key of every customer in the order table for every order. Is it right?
Right.
For every order, we put the customer name or the customer ID or the row ID. Right?
Yeah.
And then we know this is the customer. So in the order table, we should maintain something. Should we maintain something in the customer table also?
Customer table.
No?
Yeah.
Right? No. Just the customer information, but not the related information हमें कुछ नहीं करना. Customer की information करनी है वो तो ठीक है. We have to store the customer information, that's fine.
Right.
But relationships related to the relationship, something goes in the order table, not in the customer table. Nothing.
Yeah.
Just customer table has its own primary key. That's it. It already has that.
Yeah.
Not only for orders, it has for other things also.
Right.
Right?
Yeah.
So we maintain something in the
Order.
M table. That is the general rule.
Empty.
Wherever the M is.
Multiple. Okay.
Wherever the M is. So in this case, where will you maintain who? I will maintain account in contact table. Or shall I maintain a contact in account table? No, this relationship
Contact.
cannot be done that way.
Contact.
For this relationship to work, I have to put account in contact table.
Yeah.
Is it right?
Yeah.
Yeah.
Is it right?
Yeah.
Is it right? For every contact, I will mention which account.
Yes.
What is the rule? M side. M side is the rule. Wherever the M is, we'll put it. Had there been account and how had this been a one? Hafiz. Had this been account to contact been one, then
Doesn't make any difference.
it would have not made any difference. Actually, we would have kept the same row ID the way you suggested before. Yeah, right? The image is the same. But this is not the relationship between account and contact. The relationship, let's say, usually is M. होना नहीं दिखा.
Hello, Dadi.
हाँ जी. So our discussion has been so far. We made tables. We created primary keys. We put foreign keys, right?
Right.
Right? In the M side tables, right?
Right.
Right? Alright. So when we have to get the relationship back, which account, which order, what we do is we go to the order table, we get the order name, then we get the foreign key of the customer, go to customer table, match it with the primary keys, whichever is the one, then we pick all the details. Then we know this is the customer, this is the order, we put it together. Right? This is what this business logic layer does. It puts it together. Right? This business logic layer, it puts it together. Is it right? Right?
Right.
While storing it also, when an account and order is entered, it goes inside, puts it in separate table, takes the accounts key, put it in order table. Right? Foreign key. While migrating the data also, it will do the same thing. Business logic layer will work somewhere here. Right? Somewhere here, the business logic layer will work. From here, the data will come. The business logic layer will be here. Making sense?
Yeah.
Anyway, so this foreign key concept and primary key concept is clear. Right? This getting the data and storing the data is clear. That we have to store it accordingly, according to the relationships within the tables. Right? That's why I said for every now let's come back to GUI. Remember, there were two types of columns in accounts. One was the native columns, the other one were it is picking from somewhere else. For example, in opportunity. Right? Opportunity is stored in the native column, but this account is not stored in the native column. Right? I said right in that thing. This is the entity opportunity account. So account is we are making a relationship between accounts stored somewhere else.
Okay.
right? In fact, business wise also it is shown somewhere else. It is a separate entity. Table wise also it will be a separate table. Usually your business entity will correspond to a table. Usually your business entity will correspond to a separate table for itself in down the line in the database layer. Okay, and when you are making associations, that's what you're doing. You're creating that association record. You're putting the foreign key somewhere. In this case, in the opportunity table, you are putting the account foreign key. In the GUI, it is shown like this, but in the database, it is stored in the opportunity table. Account foreign key is stored. Making sense?
Yeah.
Making sense?
Yeah.
How many opportunities are there? It named 54, right? So let's make an query here. 54 rows in the query, right? It is same. Let's see the names here. Okay, devices for new examination center, right? This is one of the names. Let's see the name, one of the names here. Right? This is here, right? But it is not very eye friendly, right? You don't like to see it this way, right? It is much easier to see here, right? Right? There is a hyperlink, there is a different color altogether. But this is the way it is stored here. Devices for new examination center. Let's see what is the foreign key. Okay? It is called as PR underscore. By the way, this is the row ID of Opti, right? Let's see the row ID of org.est also. This is the org ID. Okay. What is the name of this thing? Let's pick one. Then we'll analyze that. 100 people at CHS. Is it okay? We'll analyze this one. Okay. A&E department is the. I'll put this one. AC research is the account, right? Right. So let's look for AC research here. Name. Let's do it easier way. See this AC research. We'll go to AC research and we'll find out the row ID of this guy. The row ID of this guy. This is the row ID of this guy. You come back here. Right? This is AC research. Okay. So let's see. This is a row ID. Let's see what is the row ID for this opportunity. 100 people at CHS, right? Here, this is the one, right? What is the PR underscore OU underscore DEPT ID? This is PR underscore DPT underscore OU underscore ID 1-4SOP. The row ID of AC research is here. Is it right?
Right.
You remember that?
Yeah.
Right? So let's change it. Let's change it to something else. Advantage pharmacy. Okay? We pick it. It is stored now. I slap off the record. It is stored now. It's advantage pharmacy. I go back. Execute the same query. Let's go there now. PR underscore DEPT underscore OU underscore ID, right? Where is that opportunity? 100 people, right? Right? Top one, right?
Yeah.
100 people. 1-34H. Shall we cross check whether this is the row ID for advantage pharmacy? Shall we cross check? We come here, we check it. This is the row ID now stored here. right? Right. So the way it works is, it puts the row ID as the foreign key in the opportunity table. Making sense?
Yeah.
Right? This is the way they pretty much store all the relationships. Who will tell you which is the prime foreign key here? I will tell you. Or you can go in the Siebel development environment and see it. Or you can go to Google, you can find it. Or you can go in the Siebel bookshelf, the manuals of Siebel, and you can find it. Okay?
Yeah.
There are various ways to do that. You can do it, you can find it. But best way is going to Siebel tools. Easiest way is Google. If Google does not show, then there is a problem. Then you go to bookshelf. You go to the DMR core also, right? There are many ways to do that. We'll find out various ways. But in general, you'll be given a diagram. And you don't need to know what are the foreign keys for everything. Just for 7 or 8 main entities. Okay? If there is a one-to-one relationship between account and contact, we talked about that. Then we said that they can have the same row ID. If there is a one-to-M, in contact we will store in the M side. If there is a many-to-many relationship, I'm showing it by just M and M. If there is a many-to-many relationship, then how will you store in that case? Have you any idea about that? This is the man-to-man relationship. How will you store this relationship in the tables? Just think about it, Mr. Hafiz. I'm asking, how will you store this, right? So let's see a possibility. Situation, these are the two contacts, right? These are the two contacts, these are the two accounts. You tell me, where should I store what? Tell me. Okay? We know that had this been not there, this was the only thing present, we would have simply stored this one AP, this thing here as well as here, right? Right? Is it right? But now let's say this is the relationship. Now we know that this is the relationship, right? Tell me one thing, how will you make the storage? See what you're suggesting. But where will we put this thing, that this John Smith, he works for 3Com as well as for AT&T. Where shall we put this? John Smith, he works for 3Com and AT&T also, right? Where will you put this?
Okay. So we have to assign.
And this is wrong. 3Com has 1-XYZ. 3Com has Raja Kamani, but this is in front of AT&T record. This is wrong, right?
Yeah.
Right? So how will we put it?
So we will assign John Smith.
We have to implement this relationship between this account and this contact in these two tables, right?
Yeah.
We are saying where the foreign key should be.
Foreign key should be, I think, one-to-many relationship.
See, this is not a table. This is not the table we are talking about.
Okay.
We are talking about this. How to put? I mean, I can create another table if you want me to.
Okay, no.
These are the primary keys of contact and account table respectively. This is account table, this is contact table. It should be on the M side, right? But in this case, this relationship is many to many, right?
Right.
Right? This relationship is many to many.
In account.
Me one by one, what should I really do? See, this is account and contact many to many relationship. As is shown in this data, can we put this data in these tables? That is the whole thing, right?
Yeah.
Right? So let's forget foreign keys and all that.
Yeah.
Okay. Let's try to make this thing here. Okay. So let's say this is Smith John. Let's say this is John. This is his address, 111 Main Street. Okay. This is Kirmani. This is Raja, his name. This is his address, 112 Main Street. They are neighbors. Okay. So this is 3com. That's the number of 3com. Whatever. Right. Right. Let's say this is the data you have. Now you tell me, if you have to store this relationship somewhere, where will you put it? Keys and all for the timing. The problem is not in the keys. The problem is itself is in the data storage. How will you store this data? Right? If one account has two people, two contact associated, and one contact is associated with two accounts, this and this, right? That is your riddle, right? So tell me, how will you store this information? In fact, forget this. I don't want this. I don't want this also. Just tell me, how will you store this data? So I'm doing the account first. So assuming that it should be going on the account side, I put 3com and AT&T, those two accounts. Then I'm putting the John Smith in front of them because of the fact this is John Smith here, and then this is John Smith here. This is John Smith here. But my question is, where will they put this 3com Raja Kirmani thing? In front of 3com, you can put only one. You cannot put two. Is it right?
Yeah.
Right? So account is not a good option. Let's explore other options.
Assign.
So first one is, yeah, putting it here. Let's say John Smith is here. So what I do is, in front of John Smith, okay, I will put 3com, right? Right? In front of Raja Kirmani, I will put 3com too, because he's with 3com. But where will I put AT&T for Smith John? Right?
Right.
I cannot put it here. It's just no place. Right? So
Right.
either I can make 1 to M like this, or I can make M to 1 like this. But I cannot make M to M like this with this strategy. There is some third strategy that we need. Is it right? What is that third strategy? Technique. See, either you should now allow more than one field. That's a very good observation. But then it really becomes the GUI. Database is essentially a two-dimensional array. It cannot have multiple dimensions. See your point? So that is a main fundamental rule of Excel, right? You cannot have more than 2 dimensions. I know there should be third dimension coming out of this, where all these names should be written. But that is not the way. Can you come up with a 2-dimensional way of representing?
2-dimensional way should be.
You saw it once, you said it once, let me repeat that. You said that this is the way, only way it can be done. You said that. And this is the only way it can be done.
Yeah.
The only thing you asked me, why, okay, this is the way to write it. But you didn't say, let's make a table here. Right? Forget foreign key. It is a very simple thing. You know, what we want to first find out is, you know, how should we anyway keep this kind of data? This is the way to keep this data. So relationship. So we have to maintain 3 things. This, and this, and this. If we don't maintain this third table, we cannot keep the relationships. So when there is a many-to-many relationship, we have to keep a third table. Is it right? Hafiz, can you write? So this was a hypothetical case, right? Because of the fact that we didn't want to bring the foreign keys, right? Right? Can you please draw many-to-many table for this relationships and these tables? So here I want foreign keys basically. Can you tell me what should be the keys here? So I make a third table for associations. Okay, 1-app is the code for 3com. So I've written it here. And 1-app one and John Smith ka code kya what is 1x1xyz? I've written it here. 3com's code is 1-app. Raja Kirmani's code is 1-axx. AT&T code is basically this same thing. Remember I said this should be the relationship between these. This is the way we should keep the relationship table.
Yeah.
I've just put it in the table way of the codes. Remember I was saying people start confusing it when they see the codes.
Yeah.
Please don't confuse it now. You know, it is the same thing written. The only thing is written is the codes for those guys. 3com ke liye uska code. We have written the com for 3com. We have written the code for 3com. By the way, it should have its own primary key. Because this is a third table, right? Every table should have its own primary key, right?
Yeah.
So I'm giving it its own primary key. I'll call it row ID. Okay. So it has its own primary key or row ID, right? But relationship between these two tables is stored like this, and it has its own row ID, which is a unique, as you can see. Right? So I've just written the names of those people and those companies. It is for me, it is the same thing written again here. 3com, AT&T. John Smith, Raja Kirmani, John Smith. Same thing for me. You are seeing codes, right? For me, it is same thing. This thing is same as these codes. Right? It is just our way of writing because we want to use primary keys. We don't want to use the names of people or the companies. Is it right?
Yeah.
Right? So we are using this thing, but it is the same thing. That is the reason we gave it a row ID. Otherwise, we would have used this thing only. Right? So we give it a row ID. So we want to keep these rows here. We want to keep these IDs here.
Okay, but account foreign key, you are making that in this account foreign key, you are making 3com the foreign key.
And contact also has foreign key. Both are foreign key in this table.
Okay.
Both are foreign key in this table. The only primary key is this one. Is it right?
Yeah.
Both are foreign key. So when we have to make a M2M relationship, we need another table in which we keep both the foreign keys. Do we need any key here?
No.
Where do we keep it? In a third table. Is it right?
Yeah.
Right, John? Right? We keep it in a third table. Okay? It is pretty much writing like this. I'm just deleting it from here. It's the same thing written here. Nothing different. Okay?
Yeah.
Okay. So now you know when M to M is concerned, then we write it like this. Okay? Now we understand the concept of join. Although it is a very simple concept, but I know everybody will get confused. It's a very simple thing, but let's try it. Okay? So we go back to our 1 to M relationship. Let's delete this row. Okay? Like this is the account to contact is one to many. Okay? One to many. Okay? I go back to this sheet. Why should I use the same data? Yeah, this one. No, not this one. This is the data we have. Okay. Okay. 3com has John Smith, 3com has Raja Kirmani. Okay. And in this case, names are weird, right? Okay. 3com AT&T. So AT&T does not have any contact, at least not in our sample exercise, right?
Yeah.
How shall we write it? We know that, right? we will write it like this. In the account table, in the M side, right? In the M side,
Contact.
we'll make a new this thing. We'll put for every contact John Smith 3 what is the this thing 1 hyphen app, right?
Yeah.
John, what should come here? Is to put John Smith as a contact of 3
Yeah.
So John Smith is here. We put 3 This is a 3 row ID. We put it here.
Yeah.
This thing is going here.
Yeah.
Now Raja Kirmani is also 3 guy, right? So what should we put here? We should put 3
Yeah.
row ID, right?
Yeah.
What is that?
1 hyphen app.
Yes. Right?
Okay.
So let's say there is another guy.
You have to make a row for that.
Okay. Okay. What should I write here?
You don't have assigned an account number to that.
But I have, according to this thing. There is some.
Oh, AT&T.
So what should I write here?
AT&T.
But no, I should write the row ID of that AT&T, right? So what should I write here?
1 hyphen app.
Very good. I'm so happy. You can't imagine, man. I'm so happy. How does the engine work? First, when you enter this information, engine goes, first puts John Smith details. The way I did, I first put Romani Alexander details, right? Right? Then I went back and picked the AT&T details, the row ID, put it here. Right? That's the way simple enters it. So the engine, any engine enters it. That's the way business logic layer tells it. This business logic layer tells it. Business logic layer tells database, can you please all these things here? And can you please put this app here? That's what business logic layer tells it. Okay? Okay? Now, your database is very dumb. You enter it, just the record, just like this, enter a record. So you say, enter this record and put this thing as 1 hyphen APQ. It doesn't know what is 1 hyphen APQ. For it is just a value. Business logic layer remembers 1 hyphen APQ is why I am putting 1 hyphen APQ? Because it is a AT&T. Right? So business logic layer will remember that. It is like me, working like me. For Excel, this is just raw data. He would have put anything, he would have stopped, no, he would have not stopped me from putting anything here. So business logic layer remembers. Or we design the business logic layer, making sure that this is the way data is stored. Tell me one thing. If I ask, can you tell me what is the account for Alexander Romani? If I ask the engine, how will engine go and parse it? The engine will go like this. The engine will go, check the Alexander Romani, get the account ID, go to this table and put it in front of me. Is it right?
Yeah.
If I want the account of Alexander Romani, engine will go, first check Alexander Romani, get his account ID, go in this table, get the match, see the match, get the name, put it in front of me and say, this is the guy. This is the guy. Right? Right? Okay. This is the way business logic engine will work. How will you work? You will also do the same thing, right? You will first go here, check the ID, go here and check it, right? Okay. So let's find the ID of some people like this. Then we'll see an easier way of doing that, okay? Data in this database looks pretty much like the way we have put it here. This is same thing, right? Right? This is same thing, right? So engine will go like this. It will find out Alexander Romani, right? You say, I need Alexander Romani's contact, right? Sorry, take account name. It will go to this table, find Alexander Romani, right? Go to the account foreign key, right? Right? Then it will go to go here and then see what is a hyphen APK and throw this name on the front end, right?
Yeah.
But this is very ugly. If I ask you to do like this every day, will you like it? If I ask you, can you find out the account for every contact? How many contacts are there? 3. If there are 3000, all right, there should be a quick way of doing the things, right? Let's find out. What I will do is I'll write a small program. It will go to the contact, pick the contact name, go to the account, pick the account ID, go to the account table, pick the account name, put it together. We call it query. Simple. Let's do that. Okay. Finally, Alexander Romani की वही होगा कुछ.
Click on 1-ABP. Just delete it completely and right column. I think वो जब कॉपी किया था ना फर्स्ट टाइम तो ABP के साथ में कुछ इधर उधर का डेटा पड़ा हुआ है.
वही तरीके से करें ना जो तुम्हारा तरीका है ना. Right? Is it? See, last name, first name, account name has come in front of you. Isn't it the same thing as it is written here? I have just brought it now. But did I store like this, Hafiz? Did I store like this? No, I didn't store like this. It is stored here. See, it is stored in this table and it is stored in this table. The only thing I did is in my query, I joined them. I put a rule. I told Mr. Access, what you do is you go to the database. For every you pick every last name and first name. For every last name and first name, you pick the account foreign key. You go there, pick the row ID, then pick the account name, put the account name here. Is it right? So Mr. Access is doing exactly the same thing. He's following a rule. He's just I didn't say the whole story. He just wanted for me to tell him the relationship. Rest everything is self-explanatory for him. I didn't tell him to go like this, do. But he knows all that. He just says, can you tell me the relationship? I said, all right. The relationship is this account foreign key is same as this row ID. Okay. And he said, okay, what all do you need now? I said last name, first name and the account name. I could have said row ID also. If I say row ID, he will give me row ID also. If I want account row ID also, he will give me that also. No issues. Right? Right? He'll give me everything in front of each other. Is right? The only thing he needed from me was a command. What is the relationship between these two? Other thing was, what all columns do I want? Is it right? So this is a very simple querying too. It needs what all columns you want, what are the tables you want, what are the relationships between those tables. Once you tell it, it will not get confused. It will bring all the tables automatically. Okay. In fact, I use this a lot. Every day in the office, I have to find a lot of information. Okay. Right? Shall we make a pivot table also quickly? Pivot table? Let's say I want to, right? Yeah, if I want to find out how many people work for 3Com, 2, right? But how many? Through program. Right now it's very easy, 2, but in the offices, your 3Com will be having 30 contacts. Every, okay? So let's make a simple pivot table. Right? First we'll make the pivot table. Right?
You should have a what do you call heading for the table to make a pivot table.
Really?
Yeah. Because automatically top for heading will.
Okay. So we come here, a pivot table. Okay, it's taking, right? Right. Oh, this name is not same. No, we'll make it again. I think that is the reason. Okay, I made a pivot table. It tells me how many people are in 3Com, how many people are in AT&T. Isn't this pivot table working?
Yeah.
How many people are in 3Com, how many people are in account? We made a same pivot table for your expenditure also. You know the concept of pivot table now,
Yeah.
right? You just grouped it. All right, let's see how to group it in Access. Okay, that's a querying tool we are understanding. If the data is lying in the database, how to group it. Okay, so let's make a new query. I'm deleting everything from here. Okay, you know this query, right? Right. So let's delete everything. Now we'll get we want to how many account names and count. Okay, group by, but remove group by from here. Easy, right? Very quickly told me 3Com has 2, AT&T has 1. Right? Things can become very complex, sir. It's easy, it's very simple. But I am dealing with 25 tables in my company. One has products, one has, sometimes they want me to find how many products are sold to a particular account. So accounts, I have to group by every account, then number of products. Sometimes which product is sold how many times to any account. So for every product, these are the 25 accounts which have taken it. This product, 300 accounts have taken it. This product, 200 accounts have taken it. I have to group it differently every time. Every day I'm doing that. Give me a order details by date. Today, these many records. This day, this many records. This day, this many records. Just the totals. You see your point? Remember that table? How many records were, how many accounts were created, how many accounts were referred to sales and all that? Remember that report?
Yeah.
In that report also, we were using these. So it's a lot of work, right? The only thing is, thank God we have this way of making queries. Did you see how I made the query? Group by this, just click it. It gets executed. We get the groups, right? Making sense? Okay. So we now know how to make a pivot table using Access. By the way, this is called as group by command in a querying world. There are other difficult ways of writing queries. Okay, we will learn those also tomorrow. Okay, but right for now, we discuss a lot about RDBMS. Difficult ways of querying. They are ways of querying because of the problems in the tools, not with us. You know how to make query. You know the meaning of query. You know the meaning of join. Before we go ahead, we'll understand one more thing because we are in this thing. Okay. Okay, there is a concept called as outer join. We have to study that. Okay. So if I forget for any reason, we will study tomorrow. Outer join, we have to study. We have to see a querying tool called as stored. We'll put data. We'll look at the data. We'll put data again. We'll look at the data again. We'll put data again. We'll look at the data again. Okay. Okay. So we'll do all that. Okay.
Okay.